Dear students, in this lecture we will see how a convolutional encoder will work, and also we will understand how a state transition table for convolutional encoder will be constructed. Okay, so moving to the topic, we have every convolutional encoder is represented by n, k, m, where n indicates the number of output lines, k is the number of input lines, and m is the number of shift registers used for the convolutional encoder. Taking an example of 2, 1, 2 convolutional encoder, where 2 is a number of outputs. The first 2 indicates the number of outputs, the 1 indicates the number of input lines, and the next 2 indicates the number of shift registers. This is the diagram of a convolutional encoder, wherein you can notice there is S1 and S0. These are the two shift registers. There is one input line and there are two output lines. This is one output line and the other one is output 2. So now, before the convolutional encoder begins to function, so the contents of the shift registers, that is S1 and S0, will be always considered as 0, 0. So all shift register contents will be zeros before the convolutional encoder will start to function. Now let us go to understand how the convolutional encoder will work. So here I have taken one input line, two output lines, two shift registers, and then I have two XOR functions here, okay, or adders. So now what we do? So here, since we have two shift registers, first thing what we have to understand is how many combinations of states we will get. So if I have two shift registers, there will be 2 to the power 2 combinations. That means 4 states we can get. The 4 states can be represented as 0, 0 as one state, 0, 1 as another state, 1, 0 is one more state, and then double 1. So these are the 4 different possible states that we can have if we have two shift registers. Okay, so now here I have taken the present state, that is S1 and S0 values as either it can be 0, 0, or it could be 0, 1, or it could be 1, 0 and 1, 1. So whenever we are in a present state, that is whenever we are in any one of the states out of these 4 states, suppose if I am in 0 state, 0, 0 state, I can have the input either as a 1 or as a 0. That is the reason I have written the present state as 2 times here, 0, 0, 0, 0. In one situation, the input can be 0. In the other situation, the input can be 1. Similarly, the same thing holds good for the next state, that is 0, 1 state. My input can be 0 or my input can be 1. Similarly, for 1, 0 case, input can be 0, input can be 1. Similarly, for 1, 1 case, input can be 0 and input can be 1. So this is where actually we have taken the different combinations of present states and the inputs. Now what will happen? Here the next state is denoted as S1 dash and S0 dash, and the outputs are denoted as output 1 and output 2. Now let us start functioning of this convolutional encoder. So here, when I am in 0, 0 state, let me just enter the state variables, that is 0 and 0. My present state is 0, 0 and my input is 0. So I'm taking this first case. When I take this situation, as soon as the input comes here, this 0 will be entering into this line because it is connected here. The same 0 is trying to push the contents of the shift register. Okay, so it will enter here and it will push the content of this shift register. The content, when it comes out, it will enter into this, it will enter into this, and it will enter into this. Similarly, the input will flow to this. The moment this 0 which comes out of this shift register, when it tries to enter into this shift register, the contents of this shift register will be pushed out and that content will come here. Okay, so now see, it is very important to notice that now the present state is 0, 0, but what is the next state? Next state is occupied by the content which is coming from the input, that this 0 and this 0 is pushed out and this is entered here. So now the next state variables are 0, 0. What is the output? 0 plus 0, it is a 0. Here 0 plus 0 plus 0, it is a 0. So you have a 0 and a 0. So output 1 is also 0, output 2 is also 0. So this is a when a 0 occurs. Now let us see. We will copy this first. Then we will paste it here. Yeah, now we will work out. So now this state is over and outputs also we have got it. Now we will go to the next. What happens when I'm having a 0 0 here, and my input is 1, what will happen? This 1 will come here, this 1 will go here, and this 1 will try to enter into this shift resistor. Once it enters, it will try to push the content of this shift resistor, that is 0, to this and here and here. So this will go here, this will go here, and this will enter here. Now what happens? The moment this 0 enters here, the content of this shift resistor will be pushed out and it will be coming here 0, right? So now let us look at the present state, next state, and the outputs. So when the input is 1 and the present state is 0 0, so what we got? So we got the next state as this 1 which is entered and this 0 which is entered. That means it is going to be 1 0 here. Then what is the output? So 1 plus 0, it is 1 here, 1 plus 0 plus 0, so it is a 1. So my output is 1 1. Okay, so now let us move to the next state. Okay, so the two states, input and output combinations we got. Now when we move to the next state, we will copy this one. I'll try to put it in this slide. Now what we are working? We are working with the next state, that is 0 1 state. When I'm having a 0 here, and a 1 here, so what will happen? And the input is 0. This 0 will come here, right? This 0 will try to enter into this, and the same 0 will come here also. Okay. When the 0 comes here, the content of this shift resistor will be pushed out. It will be trying to enter here, 0, and the same 0 is trying to move here. This 0 will come here, right? When the 0 enters here, the 1 will come out and it will add here. Okay, so now let us see what happens. Now the contents, the new contents of the shift resistor will be this 0 and this 0, right? So you have a 0 here, you have a 0 here. And then what is the output? So to get the output, this 0 plus 0, it is a 0. The 0 plus 0 plus 1, it is a 1. So I have a 0 1 as a output. Okay, let us take this table and we'll move to the next slide. So here in this state, what will happen? Now we are working with this 1 and this 0 1. So let us mark here 0 and 1 as a present state, 1 is a input. When I give this 1 as an input, that 1 will come here, the same 1 will come here, and that 1 will try to enter here, right? So the moment this 1 comes here, this 0 will be pushed out and it is entering here, and this 0 will go here, the 0 will come here also. The moment this 0 enters, this 1 will come out here. Now observe, this 1 and this 0 will form the next state variables, that is 1 and 0. What is the output? Output is 1 plus 0, it is 1. This is 1 plus 0 plus 1. The sum is going to be 0. So here I can get a 1 and a 0. Now let us go to the next state. So here in this state, what we are going to do, so we're going to take this 0 as input and this 1 0, right? So 1 0 and the input is 0. So when I give this 0 as an input, that 0 will come here, this 0 will enter here, and this 1 will be pushed out, it will come here, this will go here, it will also move to this position, and the same 0 will be entering here also. The moment this 1 enters here, the content of that will be shifted here. So now we have the next states as 0 and a 1. So next state is 0 and 1, and the outputs are 0 plus 1 is 1, 1 plus 0 plus 0 is a 1. So I have a 1 1. Now moving ahead. So now we are walking towards this 1, okay, this 1 and 1 0. So the present state is 1 0 and the input is 1. 1 will come here, this 1 will go here, this 1 will enter here, this 1 will be pushed out, and this 1 will go here, it will come here. So this 0 will be pushed out, right? So now we have this 1 and this 1 as a next state, and the output is 1 plus 1 is 0, 1 plus 0 plus 1 is also a 0, so it's a 0 0. Now let us go to the next state and complete the table. So here we are taking this 0, that is input is 0, and we have the present state as 1 1. So when I have this, 0 will go here, 0 will come here, and this 0 will enter here, this 1 will be pushed here, and this 1 will go here as well as here, and the content of this will come here. So now the present state is, sorry, the next state is 0 1, and the output is 0 plus 1, it is 1, and 1 plus 1 plus 0, it's a 0. So it's going to be 1 0. Now the last combinations we will work. So the last combination is this 1 with a 1 1. So 1 1 with an input of 1. So 1 will come here, this 1 will go here, this 1 will be moved, and this 1 is here, 1 will be entering out here and here. So this 1 will be coming out. So the output is 1 plus 1 is 0, 1 plus 1 plus 1, it's going to be a 1, right? So you have here the the next state as 1 1, and the output as 0. So this is the complete convolutional encoder, and how the machine will work with the different combinations of present state and the inputs and produces a next state and outputs. So this table is called the complete table. A table is called as a state transition table. Okay. So in the next video, we'll be looking into how we can construct the state machine and code trees for convolutional encoders. So till then, take care. Thank you for watching this video.